A vector is used by scientists very commonly to indicate a quantity such as force. The key behind a vector is that it has both magnitude and direction. Okay, so a vector has the combination of magnitude and a direction. Now consider a point that moves, or an object, a particle that moves from point P to point Q. So let's just talk about obtuse space here for a second. And I have a point here, P, and a point here, which I'm going to call Q. So it's moving from P to Q. Now the corresponding displacement vector has an initial point, where we think of as the tail, and an ending point, which we call the tip of the vector. And the vector v is then represented as v is equal to pq. Now, notation-wise, let's think about this for a second. Notice here, hopefully you can see it in the video, that v is in bold type. When we use, we identify vectors in the text, we use bold type. But when we're writing it, it's kind of hard to write bold text. So what we do is put a little arrow over it. You can use a harpoon, you can use a double arrow, whatever you want. It doesn't really matter. The point is that this is going to designate this thing as being a vector. So the displacement vector that we're talking about starts at P, and this particle moves all the way to Q, and this distance would then represent the total displacement. Now, two vectors which have the same length, and the length is the same as the magnitude, and the same direction, are said to be equivalent, even though they may actually have different positions. Let's think about positions here for a second. Let's draw a couple of vectors. Again, I'm going to stay in R2 for right now. So I have this vector here. They say it goes from P to Q. And then I have this vector over here that goes from A to B. Now, what this is saying is that the vector PQ is actually equal to the vector AB. These are equivalent vectors. They're in different locations, but to the best of my ability to draw this thing, they have the same length, and they have the exact same direction. So in other words, if I take a line horizontal to the x-axis and drop a perpendicular, if I call this angle theta, and I do the exact same thing here and call this angle phi, then these two angles are the same. So the directions are actually the same. And then if I take a look at the length of PQ and the length of AB, those lengths are the same. That's what it means for two vectors to be equivalent. The actual location, I could put it down here. Let's call this C and D. In this case, this is also equal to the vector CD. All these vectors are the same. The location is not relevant. What is relevant is the direction. So again, this angle relative to the x-axis, and the length of the vector.